Okay, so this is our next notes in geometry. We're going to be looking at trigonometry, which is like another branch of math, and we're going to touch on this a little bit. So when you get into Algebra 2, and especially into trigonometry, you'll have some foundation for that. So really, trigonometry, the study of the measurement of triangles, we're going to especially look at right triangles and some of the ratios that form. So we're talking about something called trig ratios. And here we can compare sides of triangles, like this one we can compare AB to BC and so on. But we can also do the angle-angle similarity, and that tells us, if you remember, that if we have two separate triangles and they share two angles, then we know they're similar triangles, and there's some ratio where equivalent sides or similar sides will have a specific ratio that will be the same for all the sides. Okay? This idea results in these trig ratios we're going to talk about. Okay? They're consistent. If it's a similar triangle, then they're always going to produce this certain number or this ratio. Okay? And then in math they use this to figure out these trig ratios. Okay? So here they are. So these trig ratios, there can be cosine, and we're going to write that COS. There's going to be sine, we're going to write that SIN, and then tangent, it's going to be TAN. But here's how they work. So here we have sine of A, and this is going to be an angle, and then we can figure out missing sides based on what we know. So with this triangle ABC, okay, we can label the sides as A, B, C like we would for the Pythagorean theorem. We're talking about right triangles here because they're the ones that are going to have a pattern. So sine is equal to the ratio that we're talking about here is opposite over hypotenuse. So if we just say A is the angle, and we can do opposite, which would be this side over here, opposite, and then hypotenuse is going to be this side. So we would just divide A by C, and that would be able to tell us the angle. Kind of cool. Sine B, we can go to the other angle, right? Go over here, go opposite, which would be B, divide that by the hypotenuse C, and it'll tell us the angle. That's sine. Cosine tells us some angles as well. So cosine is adjacent over hypotenuse. So here we have A. The adjacent is the side touching it. Okay. So we have B divided by hypotenuse C. Or we could do, go the other angle and do the same thing. And finally, tan, we have that's opposite divided by adjacent. So here we'd have, so if we go to A, it's opposite A divided by adjacent B. And you see that here, and we can go to the bottom angle and do the same thing. So they have these general ratios, and I kind of wrote some stuff in here. But there's a nice acronym, and you've probably seen it in my room on a poster. It says SOHCAHTOA. This helps us remember what goes with what. So sine is equal to opposite over hypotenuse, and cosine C is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. And if we can just kind of keep that in mind, and at first we might want to write it down and have it on an index card or something, so we remember it, then we could use that to figure out unknown angles. Okay, and we can also use this for sides in a minute. So let's say we have this triangle right here. I'm going to erase this side here real quick. So let me show you how to use it. Okay. A little example. So here we have this thing right here, and it wants us to figure out, well, what is x? Right? We know the angle, and we know one side. Okay, so when we look at the angle, and we know we want to figure out the opposite side. It's one of the legs. Okay, this is the hypotenuse. So, and we know one of the leg sides. So then we want to do, and this side is adjacent, right? And we want to figure out the opposite. So we're looking for adjacent over opposite, or somehow the relationship. And here we have tan is equal to opposite over adjacent, right? So then we could then write that out, right? And we know the angle. So tan of 25 degrees is equal to the opposite. We don't know. We'll just call it opposite for now. Divided by the adjacent, which is 18. We put the angle in. Okay. But then we know if we want to figure out this opposite, we're going to multiply 18 by the tan of 25. And then we're just going to use our calculator to figure these out. And you'll see on my calculator here, yours is probably pretty similar. Let me go closer. And there's some buttons on there. We got tan, cosine, and sine. So this one's going to be the tan 18, I'm going to plug it in, times the tan of 25. That tells us 8.39. So that's what x is, 8.39, because of those ratios. And then if we wanted to do the hypotenuse over here, so what's the hypotenuse? Okay, we could also do that. Let me go back a little bit. So we could also figure out the hypotenuse. We now know we have this one, and we want to do adjacent over hypotenuse, right? So we look for that one, adjacent over hypotenuse. It's cosine, right? So we'll just write that down. The cosine of 25 equals adjacent over hypotenuse. Adjacent over hypotenuse. So then we just plug that in again, and we know we're going to have to move this around a little bit differently because we want to figure out the hypotenuse. So I'm going to do some real quick math, and you can, some algebra, I guess. So it's going to end up being this. Adjacent equals hypotenuse. Oh wait, yeah. Ugh. Hold on a minute, let me get my thoughts together. It's going to be adjacent over cosine of 25. So we're just going to plug in whatever the adjacent is, which is 18. I'm just I'm running out of room here. So it's going to be 18 divided by the cosine of 25. That will be our hypotenuse. And I just figured this out by, I moved hypotenuse over here, then I moved cosine over here, so it's adjacent divided by cosine of 25. Then let's just do the math. Clear that. And that's just going to be 18 divided by the cosine of 25. 19.8. You can even round it up. 19.6. That's what the hypotenuse is. And that's kind of how it works. So then if we just add one more thing here. Okay. And we can also use this same idea for right triangles with like some of these equilateral triangles. And you might see some of these, you know, like we have these square root things and so on. We're not going to worry so much about that. This is just kind of an example. I just want to show you this last thing here. So inverse ratios. So we have these sine, cosine, and tangent, but we can also do the inverse of those, and that will help us figure out the angle. Okay, so like it says here, angles can be found using the inverse sine or cosine. So like I'll show you here, about the one we just did. Let me pause and I'll put it in here. Okay, so let's just say we had the triangle we just did, 18, and I just rounded this to 8.4. We didn't know the angle, so we can just write in. We have we want to know this angle. It's adjacent over opposite. Okay, and we look at our so, ka, toa. We want to use toa. It's going to reverse these, I guess. So then we'll put that over here. So that's going to be the tan. And we're going to do the inverse on this one. Well, we know what the ratio is. It's the opposite over adjacent. Plug that in. The opposite is 8.4. Divide that by 18. We do that on a calculator. And then we do the inverse now. We do the opposite. So we'd go shift our calculator, and then we're going to go to tan, and you'll see that -1 up there, and that equals 25. Exactly what it should be. So these are kind of helpful. Add this to your notebook. These notes were a little long. Sorry about that. And then we'll talk in class about it.